Okay, so I will show you the microstructure of the before the grain size is like this, and after the process of the TMCP process, the microstructure become like this. So you will find the microstructure already changed. Yeah, this is the before, and this after. You will find the grain size. Yeah, the grain. You will find the grain size. Let's find the grain size is quite different. So the grain size reduce. So it can increase the strength from bigger size to grain size to small size. So the Taipei 101, the strength of steel up to 800 megapascal. So at the end here, so I would like to end here. Next year, when you come to Taiwan, I'm very happy. I can bring you to visit the high-rise building in Taiwan. So please refer to page number 137 to look more about this, about the TMCP theory. How can they reduce the grain size? You can find from here the theory. And this is the difference of grain size from big grain, larger grain to small grain, and the strength 420 to 800, almost 2 times the strength. And we will finish in the video.
Taking the heart of Taiwan into the future. Designing and building the world's tallest skyscraper is no easy task. But here in Taipei, 2 of the most powerful forces of nature, earthquakes and typhoons, combine to make going super tall a super challenge.
I mean, any tall building in the world is a feat of engineering.
Using world-leading engineering and construction techniques, Taipei 101 not so much conquers nature, but outsmarts it.
This is the only super tall building in the world that's designed in a seismically active zone. This has never been done before, certainly not to this scale.
The result is a man-made marvel, a unique megastructure of unprecedented size, shape and technology, built to withstand the very worst that nature can dish out.
I, for one, I'm a structural engineer. If there's going to be an earthquake in Taipei, I want to be in this building. I mean, I'll choose this above all else.
And it's not just as a superstructure where Taipei 101 pushes the boundaries.
We are not only managing a building or a city of a city. I believe we are managing the symbol and landmark of Taiwan.
Taipei 101 is a benchmark of technological brilliance and innovation. A record-breaking megastructure that defies nature and puts the small island of Taiwan firmly amongst the giants of global industry. For as long as humans have been making buildings, those buildings have been getting taller. From the Empire State Building in 1931 Sears Tower in 1974, Central Plaza Hong Kong in 1992, to the recent Petronas Towers in Kuala Lumpur. Skyscrapers are buildings that go beyond functionality. They are symbols of prosperity and power, icons of wealth and industrial might.
If you're looking at the history of skyscrapers, really you begin in America. Chicago and New York are the classic cases. But in the last, let's say, 10, 15 years, Asia's really boomed with regards to the building of large structures.
In recent years, Asia has seen an explosion of mega-scale building and industry. The region now holds 8 of the world's 10 tallest buildings. And as modern construction methods and materials continue to improve, designers will continue to aim ever higher. Not because they have to, but because they can. Developer Harris Lin is one of the most powerful and successful businessmen in all of Taiwan. A member of a major construction dynasty, for him, Taipei 101 is the result of a lifelong ambition.
Since I was a boy, I have dreamt that one day I would build a great building, one which will benefit later generations for a very long time.
For Harris Lin, Taipei 101 is more than just a building. It's a statement on Taiwan, its people, and its future. A notice to the rest of the world that Taiwan has the technology, the industry, and the determination not just to join the giants of global industry, but to lead them.
There's no better way, really, of getting global attention than building these super tall buildings, particularly if it's the highest in the world.
Initially earmarked as the centerpiece for the growing and glitzy Qiangshan district known as Taipei's Manhattan, the primary goal for the building is to be the best, but not necessarily the tallest. Long-standing friend of Harris, architect C.P. Wang from C.Y. Lee & Associates, comes into the project in the early stages.
We started with 3 buildings, a 60-story building in the center and 2 smaller buildings that are about 20 stories for the different shareholders.
But plans quickly evolve as key investors clamor to have the building push up, not out. The planned 60 stories soon turns into 88. And with the mantle of the world's tallest a mere 13 floors away, the momentum becomes unstoppable.
We truly believed we could do it, that if we worked hard, we could make a building that was visible to the entire world.
But 3 factors combine to make this project not only the tallest and most visible in the world, but also one of the most difficult to build. Taipei City is an inhospitable place to build a skyscraper. Beneath the earth, a thick layer of soft clay demands uniquely designed foundations. While above ground, the threat of earthquakes and typhoons requires a level of engineering and construction never before achieved. If Harris Lin wants to make the tallest building in the world here, his engineers and builders will have to confront the power of the earth. Designing a structure flexible enough to resist an earthquake, but stiff enough to resist a typhoon. Contradictory requirements that until now have never been combined.
All of these different mixtures of elements have to be blended almost superbly in order to make the building achievable.
The solution will combine 2 revolutionary systems. First, a braced megaframe joined to 8 super columns filled with a mixture of steel and concrete. And a tuned mass damper, a giant pendulum, the weight of 10,000 people, designed to oppose the effect of wind. The combination of these 2 concepts is groundbreaking.
I am very proud of it, and as architect, you don't get a lot of opportunity to work on something of this magnitude.
Construction will take 6 years, 2,000 workers at any one time, and 700,000 tons of the most advanced steel and concrete ever made.
These cost more than the national GDP of some countries.
Yet despite all the investment, ingenuity, and determination of humankind, the forces of nature can strike at any time, whether you're ready or not.
Okay. And we directly go to the factory. Yeah.
Workforce. It's a construction army.
Actually, the steel for Taipei 101, we pay 2 billion Taiwan dollars to the Japanese to get the patent, and we set up the factory to produce the TMCP steel in Taiwan for Taipei 101, and the steel is produced by small grain size as a TMCP steel. The meaning is we use the steel small grain size inside here, inside. That we pay. That we already pay.
Each joint, steel, a complex chemical cocktail of carbon, alloy, and refined iron. More carbon makes it stronger, but too much, and it becomes stiff.
Yeah, so this factory in Taiwan, we pay 2 billion NT dollars for the patent to produce in Taipei, for the Taipei 101. So this is a new story. It's a real story and a real application for this technology. Yeah. Okay. Everything finished here. Now, so still we finish at this moment. So you want to learn more about steel? Please go back to our I have many reference book for you for steel. So if you want to learn more, you can go to the books. I remember I have a chapter. I may go back. I encourage you how to learn steel. I remember I proposed some methods for you. I try to find this because a student asked me how to learn where for steel, and because this learning is different from the traditional method. So we need to use some new concept to learn the material. Yes. I forget where. Yeah, sorry. So maybe I show you. Yeah. Okay. If you want to learn more, please refer page number 2 of our document, page number 2. We have some reference book to read. And also, again, Google and YouTube is also your very good way to find your solution. So good luck. Good luck. We still will finish here. And from next week, we will go to new subject, new knowledge about the green material for civil engineering. Thank you.